la prima memoria, che sarà portata dalla dottoressa Marie Carey della Birmingham City University ed è intitolata In che modo l'artigianato e le tecnologie digitali forniscono soluzioni per il settore dei beni culturali. La dottoressa Marie Carey nella sua carriera accademica ha combinato le capacità artigianali tradizionali dell'oreficeria con i progressi nella tecnologia laser. Ha lavorato con importanti argentieri britannici e operatori del mercato dell'oro. In collaborazione con il Birmingham Museum Trust ed il Museo di Londra, ha utilizzato le sue capacità artigianali per ricostruire oggetti di valore storico-artistico. Prego.
Thank you. So today I'm going to talk about an actual case study that we had at the school. And it's a project that we did between ourselves as the School of Jewellery and the Museum of London, which is a major national museum. Now, museums have a very difficult and often conflicting balancing act to achieve. They are custodians of our cultural heritage, so they have a responsibility to preserve and protect the artifacts within their collection. But also as public institutions, they have to provide access to their collections for public engagement and scholarly activity. So it's quite incompatible, really, their demands. What we tried to do with this project was blend digital technologies and craftsmanship, and how do those provide opportunities to bridge these opposing demands? In this paper, we can respect our traditions while at the same time embrace digital technologies. The Cheapside Hoard. Now, a little background. If you don't know about the Cheapside Hoard, it's a Jacobean and Elizabethan time capsule of craftsmanship. Approximately 500 items, buried at some point between 1635 and then forgotten for 300 years. The hoard was discovered by chance in 1912 by workmen removing the cellar floor of the 17th century building that stood on Cheapside, an area that is historically known for its goldsmithing and close to St. Paul's in London. After some legal wrangling and shenanigans, as I would call it, over the ownership, the hoard eventually went into the custodianship of the Museum of London. Now, jewellery of this age and in its original condition is exceptionally rare. Jewellery is not normally thrown away, but it's often at the mercy of fashion, fortune, reworked, refined, and sold on for its intrinsic value. So this is exceptionally rare to have this amount of material of that age. As a school, we worked with 10 artifacts from the collection in readiness for their exhibition in 2014. And this paper is going to talk about one of those artifacts in particular, the pearl dropper, which you can see here on the right. It's a beautiful cage structure of 18-karat gold wire with enamels and some evidence of pearls on it. We started off with basic craftsmanship observations. We took some study days in the Museum of London's basement, and we took as many images and photographs and measurements as we could, just to try and understand the construction of the piece, how it was possibly fabricated, because looking at a piece for its aesthetic qualities is quite different from looking at a piece to working out how it was made and how we were possibly going to remake it. It is slightly squashed, not deliberately broken up for recycling, So the assessment was that it was probably not a robber's loot of jewellery, but it was actually a jeweller's stock in trade. An everyday object that might have been part of the spares of a workshop. But having looked at its construction, it was an ideal candidate for recreating a handleable object for the museum. The museums keep their precious artifacts behind glass, but what they wanted to do was engage with the public in terms of having objects they could handle. So they contacted us and asked whether we could help them solve that problem. So we started to develop our thoughts into CAD models. And we started with some quite simple rendering, quite simple CAD file rendering in terms of Rhino. We realized that what we were looking at was a skeleton of the intended construction. And what we really needed to consider was we were looking at an object that had been in the soil for 300 years. It was probably missing elements of its construction. There was evidence of flaky enamels at the top of it, and there were also a number of different gauged wires. Interestingly, quite a difference between those gauges, some of which were soldered in place and some of which were mechanically attached. So were those elements that were mechanically attached holding something that was heat sensitive? Could these circles have held pearls? The size of the jump rings also determined the size of the pearls, and the larger setting at the bottom may have contained a pearl or a half pearl. So combining these observations and with looking at contemporary portraits of the time where pearls were very much in demand, we decided to kind of step back and think, well, how would it have looked when it first left the workshop? So it's quite an engaging piece when you start to look at it in terms of how it may have looked. Now, how do we translate this into a metal object? We showed this to our casting technicians, and we had quite a long conversation about voids and thin amounts of wires, and could it be castable, and was it one of Therese's possibly horrible casting designs. So we used our in-house Envision 3D system at the time to print a two-part wax. Part wax in terms of build and part wax in terms of support. Now I mention that because this was the first time we actually put our CAD file into a three-dimensional form. And when we were using that printing system, the supports could very easily be taken away. It could be placed in an oven, you had a tissue underneath, and it soaked up all the support wax. Now I mention that because of what happened next. We then got into discussion with some of our industry partners about whether DLS, direct laser sintering, might be a process that we could use. And the comments that came back was, possibly, let's give it a go. So at the time, we realized that we were jumping outside our comfort zone in what we understood of 3D printing. Normally it would go 3D printing straight to lost wax casting, but we were asking to go to use it for DLS. And at the time, there were papers on it, there were books on it, but we had no practical hands-on experience of how that metal would behave. So ES Technologies offered us some build space, and we thought, well, this is actually a really interesting opportunity to try out DLS, but trying it out and trying it out on a live project is quite a risk. This is what came back in the post. That was not what we'd expected. So we'd sent off our CAD file. The DLS company had put the supports in place. and we had more supports than we had build. So this was our first concern that was raised. We did want greater flexibility. We needed greater flexibility, and DLS seemed to be the right choice, but maybe we weren't approaching it in the right manner. We knew very little about how craftsmanship integrated with DLS. I then spent several hours with a pair of tweezers removing all of those supports. I think the main lesson that came out of this, which is much easier to edit your supports in your CAD program than it is in the physical piece. We reported back our findings to the company, and they were quite gracious actually. They said, let's keep working on this together, let's see if we can find a solution. And we actually thought, this is really quite generous of them. They're prepared to start working with us and find a solution. It wasn't, oh, you've not done this properly, oh, you've not done that properly. It was, let's work together. What we realised from our perspective was that the first print that we put together was in stainless steel, and it was an exact recreation of the metal components of the pearl dropper, but built as a single unit. So therefore, the physical access between the wire arms of the cage structure was very limited, making it impossible to accomplish the downstream activities. In order to incorporate the additional finishing of pearls, enamel features, greater access to the structure was required, and therefore a rethink of the fabrication was required. The final design had to remain the same, but we needed an intermediary manufacturing point. So we reconfigured the CAD file to accommodate the post-processing additions. So as such, we were reverse engineering it for the manufacturing route we were going to take. We then had that CAD file built, and we had substantially less support structures, but we had interesting missing elements, and maybe elements or layers that didn't build properly. We also realised that in our first print, because of the way that the cage had been constructed, there were a number of contact points between each of the rings. So therefore it was actually quite a strong structure. When we made it with an open structure, it was actually quite fragile, and it was really difficult to post-process and finish. So that was a lesson for us in understanding the behaviour of the sintered metal and getting the design right. We decided to have another think. We went back to our CAD. So by this time, we'd been working in CAD, printing it, going back to the CAD, reprinting it. So we were going back to the CAD again. So when you read these papers about 3D printing, it's all quite a linear process of you do this, and then this happens, and then this happens. But actually, when you're on a learning curve to understand these processes, the unexpected happens. And that's not covered in some of these papers, so you have to kind of think on your feet. These amendments to the CAD file were made specifically to allow the assembly process after the printing to progress smoothly. So on the right-hand side, we recessed a slot for the pearl arms to sit into. And on the top of the enamel arms, we tapered the arms. And that was purely to make the next stage more easy. What we decided to do in the end was more of a hybrid approach, where we built the enamel arms as a cage, and that gave us strength and structure. And we built the pearl arms separately. That would allow us more access for finishing, and also for us to be able to put the pearls in place. So when you look at the number of files we did, we actually realized that we'd gone right back to the original form for the enamel arms, but we'd slightly amended the pearl arms. We wanted to construct as much as possible through the DLS system, but also have the flexibility. So we felt that this approach would be the best one. And in this stage, we also worked directly with ES Technologies in terms of the CAD supports that they were putting in. So the supports were really quite minimal. So this is one of the laser sintering layers that was done, and video kindly taken by Colin Cater at the time. And that's the one in stainless steel. Now, we also had one, the next stage, where we put 6 down. We decided to build it in bronze. And we were sent through this video via email. And I have to say, it was quite anxious watching this video. We knew what was in the powder bed. We knew what we'd sent through as a CAD file. But had it succeeded, had it built properly, had it built with no breaks in it, was it going to meet our expectations? It was quite interesting to think that our excitement kind of paralleled probably the excitement of those workmen in 1912 when they discovered the hoard, removing it bit by bit from the bed. So this is a video of after the build and the build platform being raised and the removal of the loose powder around it. So at this point we're still holding our breath to make sure that it's all built properly. So we managed to remove the components without any breakages from the build platform, and then it was time to take it to the hand finishing and the bench. And this was a real comfort for me because I felt much more confident in this stage of the process. For me, when the builds come off the machine, they're still components. It's only when they come off the bench that they become the product. So I spent a number of hours removing supports and cleaning up the surface to be as consistent as possible, ready for the downstream activities. This was actually a real confidence boost for me in terms of getting to know the metal, in terms of understanding how taking a file to it, how taking a polishing motor to it, how it responded to some of those processes. I think because of the uncertainties we'd had in the CAD file and the build, I needed this time to get to know the metal. I needed this time to get to know the metal as a craftsman, and to give me confidence in the next stages. And it was at this point that I actually thought, do you know, this might actually work. Now, we'd had it built in bronze, so the next stage for us was to give it more of a look of the 18 carats. So we did our in-house plating and cleaning up. And you can see from the picture on the right the difference between the bronze and the gold. And I think you can just make out on the right hand side the little recessed slot we made in the base plate to accept the pearl arms. The next stage for us was adding on the enamel. on the original pearl dropper, the enamel has a really bulbous look to it, so it sticks quite proud of the setting ring. So that requires layers and layers of enamel to be added. It's quite a patient process. You have to be quite patient with it. And we like to keep things simple at the school, so our tool of choice is a wooden cocktail stick. So I like to think that this whole process has used tools from a very expensive DLS machine to a wooden toothpick, but it's about using the appropriate tools for the appropriate job. So by this time, we'd got quite a jigsaw of a puzzle. We'd got the sintered parts, we'd got the sintered arms, we'd got the pearls that are all graded in size, and we'd got the fine gold wire that we were going to attach them with. It was now time to go back to the bench and sit there very patiently going through all of these pearls. We did a number of trials in copper because it turned out that that first loop on the bottom of the pearl dropper arm was really important to get the tension right in the wire and get the tension right without kinking the wire in the wrong way. Once you got that first pearl on, the rest of them seemed to follow suit really quite nicely. And I was having an awful lot of problem in doing this, and I thought, this is a simple twisted wire. And I just want to tell you about a small observation I made at this point, sitting at the bench, actively doing and engaging with this process. I went back to the original photographs of the pearl dropper and thought, why am I finding this so difficult? And I noticed that the pearl dropper twist was slightly different to mine. I am right-handed, and I naturally twist my wire clockwise. I looked at the pearl dropper, and it was anti-clockwise. And I just thought, I wonder if that goldsmith 400 years ago was left-handed. So this is some of those little things that you pick up that I wouldn't have observed, but for the fact I was actually trying to recreate it. So at this point, it's time to try and assemble all the components together. And this was the laser welding. As you all know, pearls and enamel are incredibly sensitive to heat. So it was very important that we had a real clear line of sight. Having that little slot in the bottom of the pearl dropper was absolutely brilliant because it made it really secure in terms of the positioning of that piece. And it allowed the whole thing to come together really quite smoothly. Surface texture. Now, I know that Teresa mentioned this before, and I would say that things have improved, but it's quite interesting to note there's quite a significant difference between the sintered material and the wire. And I think that is something that will continue to be an issue in our industry. When I got to this point, I was very pleased. And I think in homage to our trip yesterday, I might call this a Three Graces. So this was the photograph that we actually sent off to the museum and said, well, we're at this point now. How do you feel about it? Response back, can we have them tomorrow, please? So they're not quite finished yet. There was the final, what we called the pearl finial, a kind of chandelier aspect at the top. And that was probably the most damaged element of the whole piece. So we had to take a degree of artistic license in recreating that piece. And we did this for all the pieces. So this is the journey, really. This is from the original artifact on the left all the way to the handling exhibit on the right. Quite a journey, quite a lot of learning, quite a lot of mistakes, but that's all part of the process. There were definite moments of complete frustration with trying to understand this new technology. Oh God, that's obvious. Oh, that might actually work. And then, of course, the sheer delight when people pick it up and actually handle it and hold it. So we did make lots of mistakes. But would I do it differently? Actually, we needed to learn those mistakes, because you do remember your mistakes, and we learn not to do them again. And hindsight's a wonderful thing. For me, learning through practical experience is incredibly valuable. And as a team that worked on this, I think we learned an awful lot. So these pearl droppers went off to the Museum of London. And if you perhaps Google Cheapside Herd pearl dropper, there are a number of images on the web now of people actually holding this artifact, which is exactly what we wanted to achieve. You know, the hoard is predominantly jewellery. It has a relationship with the body, but yet within a museum environment, we are detached from it. It is behind a case. You're not allowed to touch it, not allowed to hold, feel its weight, understand how it was worn. And all of a sudden, we have this happening. And the excitement is just amazing. At the museum's private view, I had an experience which I'd never expected to have, where a lady who was partially sighted held the object. And she read it with her fingers, not visually or relying on the comments of somebody else. And her face just lit up. And everybody who was talking to her stopped, because they could realize the really important and significant impact it was having on that particular individual. And it's small stories like that that make this project really valuable. Now, we are not all work and no play. So I'd like to introduce my colleague, Keith Adcock, who, as you can probably just make out, is wearing the pearl dropper as an earring. Now, this is actually quite usual for 17th century gentlemen. They had a particular penchant for pearl earrings, particularly big pearl earrings. So at our school, we do take our work very seriously, but not ourselves. And now and again, we like to combine the two. So this photograph is presented here with Keith's permission, taken on my phone at the very end of a very long day at the museum, engaged in private view activities, which might have involved some alcohol. It goes along with the completely British tradition of seaside cutouts and having your photo taken and being able to laugh at yourself, really. Finally, I'd just like to thank all the people that were involved in this project. They were an amazing people, a group of people with really generous amounts of knowledge and being very solution orientated, trying to find and solve problems for me. I'd also like to thank Lagore for giving me this opportunity to tell the full story. I presented some of the research behind this story at Santa Fe a number of years ago, but I hadn't got to this stage yet. So this is really nice to tell the whole story. And now this piece from the pearl dropper is actually in the Museum of London's collection. It is there for them to bring out for handling exhibitions, and it's part of their learning experience. Thank you.